So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which we are gonna be proving this amazing identity, right? Okay, so first of all, I'm extremely sorry, guys, that yeah, I apologize in front of you all that it's been 2 weeks that I posted a video, right? And I'm so sorry about that. I actually, let me tell you the exact reason. It was I was kind of you can say I was kind of having a lot of uh, you can say problems, and I cannot tell you the exact problem right over here, but yeah, you can understand if you can just check out my bio. So like uh, about me on my channel, so you can understand that yeah, what kind of problem that I would be having. I must be having right now, and yeah, and this gap that is my last video and this one it's around 2 weeks. It's been around 2 weeks, and this is the longest gap that I have ever taken like in publishing videos on my channel. So yeah, I'm extremely sorry guys. I was literally out of my journey. I was literally out of my track. So for that case, I'm so sorry, but yeah. And again, I'm not stable yet. I'm not settled down yet, and I'm having problems yet. So for that case, I think it's gonna be like I'm not sure. My next video, like when I'll be posting my next video, but yeah, surely I'm just trying it out. And but yeah, so I just thought like I just got a time, I just got some time. So for that case, I just thought let's just bring some video, let's just bring a video for my guys, for my people actually. So yeah, let's just talk about this. I know this is not that amazing, but it's all right. We are gonna be proving some like exponential stuffs, equals times some infinite products right over here. So yeah, and yeah, just believe me, it's gonna be easy, right? So let's just dive into it. Okay. So basically what we have to prove is we have e to the ax minus e to the bx equals a minus b times x times e to the 1 over 2 times a plus b and times the product as k goes from 1 to infinity of 1 plus a minus b whole squared times x squared over 4 k squared pi squared. So that's what we're going to prove in this video, and believe me, it's going to be easy. And the thing that you have to know is you have to know about this thing, hyperbolic sine function. And yeah, we have talked about this multiple times, several times. So if you're a daily viewer of my channel, though it's not a daily channel actually, because it's always been 2 weeks that I post my last video, but it's all right. It used to be, right? You know that, right? Okay. So you must have encountered this thing, right? So basically, it's sine of h. Actually, this thing, this h denotes the hyperbolic sine function. So since we can pronunciate it as sinh of x equals e to the x minus e to the minus x over 2. So basically, this is the definition actually, right? And now what we're gonna do here is we have to talk about this. But before that, let's just talk about the relation between the hyperbolic sine function and the actual trigonometric sine function. So basically, we have to talk about. Let me just change the color. I think I should just change this out. Okay, so we have relation between sine of x and sinh of x. Actually, I'm sorry. Yeah, x. So okay. So yeah, from Euler's formula, should I go with this in deep? I think let's just go. Let's just go deep with it. Okay, so we have the extremely famous Euler's formula, right? That says e to the I z equals cosine of z plus I times sine of z. So this is the extremely and amazingly famous Euler's formula, right? We know that I have proven couple of times this thing. Like I have proven this thing couple of times, so you can consider watching those videos if you want. Okay, so here if we consider replacing z with minus z here, so we're gonna be having e to the minus I z equals cosine of minus z plus I times sine of minus z, right? Okay, let me just change the color. And we have two equations right over here. This is the first one and this is the second one, right? So wait a second, I don't need to consider this early, like this early. Actually, I need to talk about this equation first. So wait a second, what happened? Okay, so we know that, right? Yeah, like cosine of minus stuff is just cosine of stuff, right? And sine of minus stuff equals minus of sine of stuff, right? So these two things you must be like knowing these two things. So yeah, I'm just considering these two things. So for that case, we have e to the minus I z equals cosine of z minus I times sine of z, right? Okay, so if we talk about this as first equation and this one as second equation, so if we just write the first equation right down here once again, so that's going to be giving us, I'm just copying out this stuff that we are having. Okay, so I'm just gonna what I'm gonna do here, I'm just gonna subtract the two equations. So subtracting the two equations, so minus, minus, and minus, right? So basically, take a look at this. Cosine of z minus cosine of z, we would be getting rid of that. So it's e to the minus iz minus e to the iz equals minus I times sine of z minus I times sine of z. So yeah, so we are having these kind of things. And now we can say e to the minus iz minus e to the, I'm sorry, wait a second, yeah, e to the I z equals your minus 2I sine z here, right? And now I'm just going to multiply both sides with negative sign. So basically we have negative and that's going to be giving us positive, because negative times negative is positive, we know that. And from here we can isolate sine of z as sine of z equals e to the iz minus e to the minus iz over 2I. So this is your sine of z when you express this sine function in terms of some exponential stuffs, right? Okay. And now what's the motive of this thing, right? In this video actually. You know what? I'm not talking about this thing um, here. I'm just making this the, you can say, the foundation firstly, and then we'll talk about that, right? Okay, let me just add a page here. Okay, we have, so basically so far we have proved that sine of z equals e to the iz minus e to the minus iz over 2I. Okay, and our next step is, let's just talk about, well, we can talk about sine of iz, right? So sine of iz is gonna be e to the I times iz, right? Basically I have just replaced z with iz, so basically this z is gonna be iz. So we would be having this iz is the argument, right? Okay, and minus e to the minus I times iz over 2I. And we know that I times I is minus 1, right? So basically it's e to the minus z minus e to the z over 2I. And yeah, from here we can take, or you can say, yeah, so basically we are having so far we are having sine of iz equals e to the minus z minus e to the z over 2I. And I'm just going to multiply both sides with minus I. So minus I times sine of iz equals minus of I, and it's e to the minus z minus e to the z over 2I. And I cancels out, and this negative will just be being multiplied to this parenthesis. So basically we would be having minus I times sine of iz equals e to the z minus e to the minus z over 2. And guess what? From the very first page, let me just get over here. We have considered, like we have took the definition of sinh of x, that is the hyperbolic sine of x, as e to the x minus e to the minus x over 2. And what we have got so far, we have got the same stuff. So basically it's your sinh of z. And finally we can talk about the relation between you can say the sine function and the hyperbolic sine function, right? Basically the trigonometric sine function and the hyperbolic sine function. So the final relation actually that we have got so far is relation is um, sinh of z equals I times, oh wait a second, actually I need to talk about minus I as well. Wait a second, minus I times sine of iz. So this is the relation that we have got so far. And why did I do that? Wait a second, actually, you know what, why we are doing these kind of things? Because we need to talk about, wait a second, we need to talk about this infinite product. So for that case, I'm just going to talk about this. So actually, I need to talk about that. Okay. So we have what we have got so far. We have sinh of z equals minus I times sine of iz. Right. Okay. Do you remember, guys, that we have proven the Euler's infinite product of sine function. Do you remember, guys? Please don't forget about that. That's extremely important. So basically it was sine of z over z, or you can consider x instead of z actually, because I need to do, I don't want to get confused with some variables. So we have, wait a second, let me just use red color. So we have sine of x equals x times the product as k goes from 1 to infinity of 1 minus x squared over, wait a second, I'm sorry, yeah, k squared and pi squared, right? So yeah, this much thing we are having here. Now, so basically, I'm just going to talk about the infinite product of this function, that is the hyperbolic sine function. Now, how I'm going to do that? Because I'm just having the infinite product for this sine function, so we can use this relation and this relation to find the infinite product of the sinh function. That is, let's just talk about this, guys. Okay, so basically we are having the argument here as iz. So let's just replace x with iz here. So that's going to be giving us sine of iz equals iz times the infinite product, that is product as k goes from 1 to infinity of 1 minus I squared and z squared over k squared pi squared. And guess what, guys? Look, this thing is just -1. So -1 times -1 is just +1. So basically we would be having sine of iz, like the successive term of that thing. So it's iz equals the product as k goes from 1 to infinity, and it's 1 plus z squared over k squared pi squared, right? And we are not done still yet. We are not done yet, right? We have to talk about, like, we have to multiply this thing with minus I. So that's going to be giving us like if we multiply here, so multiply with minus I, so that's going to be giving us minus I times sine of iz equals minus I times iz times the product as k goes from 1 to infinity of 1 plus z squared over k squared pi squared. And next, if we talk about, so we would be having minus I sine of iz equals, look here, your I times I is -1 and negative times negative is just positive, so basically we would be having z only. So we are having z times the product as k goes from 1 to infinity of 1 plus z squared over k squared pi squared. And guess what? From this very equation, we can say that this product is also equivalent to hyperbolic sinh, or you can say hyperbolic sine of x. Actually, z. I'm sorry. It's not x, but z. So that's how we derived an infinite product that represents the hyperbolic sine of x. I'm sorry, z. Let's just consider z. So sinh of z equals z times the product as k goes from 1 to infinity of 1 plus z squared over k squared times pi squared, right? And now we are gonna be playing around with this only. So that was the motive. Actually, we have to reach up to here, and for that case we did went through from these things actually. So yeah, okay. And now let's just talk about the main thing that we are here for, that is the this thing that we have to prove. That was e to the ax minus e to the bx equals e minus b times x times e to the 1 over 2 times a plus b and times the product as k goes from 1 to infinity of 1 plus, wait a second, sorry guys, I need to just yeah, 1 plus wait a second, it's what was that? Let me just check this out. Yeah, it was a minus b whole squared x squared over your 4 k squared pi squared. So that's what we have to prove here. And now let's just begin the proof of this thing after looking at this infinite product. Obviously, we can relate it with this thing that we have just derived here. So obviously, we have to do that. Or let's just talk about this here, right over here. So basically, if we replace, like in this equation, if we replace z with a minus b times x over 2, so that's going to be giving us, like I'm just going to write that down here, so it's sinh of a minus b times x over 2 equals z, right? So that this one actually, so it's again a minus b times x over 2 and times the product as k goes from 1 to infinity of 1 plus, so if you replace z with a minus b times x over 2, so that's going to be giving, if we squared it, so that's going to be giving us a minus b whole squared x squared, and the square of 2 is just 4, so it's 4 times k squared pi squared. And guess what, this is the exact product that we are having in the stuff that we are here to prove. Just take a look at this. So that is why we did all the things, and all the, that is why we are here and with this result. That's why I don't want to use that result right out of nowhere. And then you would imagine that how did Aman use this? Aman used to claim that I don't use anything without proof, but now he's just using it out of nowhere. So that's why I just took some 12-15 minutes, I'm not sure, and that's why I just proved this down. Okay, so let's just talk about this furthermore. Okay, so basically, if we isolate this infinite product from this very equation, so that's what we're gonna get. We're gonna get sinh of a minus b x over 2 over a minus b x over 2 equals the product as k goes from 1 to infinity of 1 plus a minus b whole squared x squared over 4 k squared pi squared, right? And so and more precisely we can say it's 2 times hyperbolic sine of a minus bx over 2. Wait a second, I need to be, actually my laptop is quite hanging, I'm not sure but what's going on here, but it's all right. Let's just go through it. So basically we can replace this infinite product, right, with this quantity. So let's just talk about this in our actual stuff that we are here to prove now. So we have e to the ax minus e to the bx equals, we were having a minus b times x e to the, it was 1 over 2 times a plus b, and we have 2 times hyperbolic sine of a plus, oh wait a second, I'm sorry, it's a minus b. Yeah, so it's a minus bx over 2 over your a minus b times x. And guess what? We are successfully getting rid of those things, this one and this one. And so further we are having e to the ax minus e to the bx as e to the 1 over 2, or maybe we can consider writing 2 like you can say here, and then we consider writing this one. So e to the 1 over 2 times a plus b and times hyperbolic sine of a minus bx over 2. And now, guess what? Guys, do you remember that the relation between hyperbolic sine and the e like exponentials that we have discussed on the very first page, that is this one, this relation. So that's what we're gonna use there. Wait a second. Yeah, here. So basically, we have talked about the very first thing about the hyperbolic sine function, that was hyperbolic sine of x, or you can say z. Let's just talk about z because we are having x there. So it's e to the z minus e to the minus z over 2. And we are having the argument that is z if we compare it down. So z equals a minus b times x over 2. So that's what we're gonna do in the next step, and that let's just see what we are having, right? So yeah, this is the beauty of mathematics. If you just begin to just dive into it, so nothing will stop you guys. Yeah, I think it's amazing. So we are having e to the ax minus e to the bx equals 2 times e to the your 1 over 2 times a plus b, and we were having e to the a minus b times x over 2 minus e to the minus a minus b over 2 times x over 2, right? If we successfully replace z with this very argument, right? So that's what we're gonna get right over there. And again, we just got rid of this 2's actually, right? Okay, and we are having e to the ax minus e to the bx equals e to the 1 over 2 times a plus b times e to the, you can say 1 over 2 a minus bx and minus e to the minus your 1 over 2 a minus bx. And now what I'm just gonna do in the next step is I'm just gonna multiply this right over here and right over there as well, right? Okay, so that's good. But that, let's just see what we're gonna get. So it's e to the ax minus e to the bx equals e to the 1 over 2a plus 1 over 2b. Actually, I'm just expanding this. We know that if we just multiply this, so the bases are same. So the exponents are just gonna being adding up. Oh, wait a second. Actually, I'm just missing something here. I must haven't noticed it. Yeah. Oh, wait. I'm so sorry, guys. Again, I just did a blunder here. That is, I just left this x. I'm so sorry, guys. There was X over there, and that is where I just realized that I wasn't having this stuff actually, and I'm so sorry. Don't think that I just included myself by myself that X over there. It was there, but I just forgot that to write over there. So it was X. Like, just look at this, guys. Actually, I just forgot that. I'm so sorry. I'm so sorry. Okay. So yeah, so that's why we are having x here and x over here as well. And that's where I was like thinking, what's going on here? Okay, so we have 1 over 2 times ax plus 1 over 2 bx and plus 1 over 2 ax as well, and minus 1 over 2 bx. Like, I have just expanded this one, and this after expanding this, I have just added after the expanding of this one as well, right? And for the second term, the same stuff, e to the 1 over 2 ax plus 1 over 2 bx minus 1 over 2 ax plus 1 over 2 px. And guess what? Obviously, we would be having a lot of cancellations right over here. So we were having these two things getting cancelled out, and these two things are getting cancelled out as well. Right. And we have e to the ax minus e to the bx equals e to the 1 over 2 at ax plus 1 over 2 ax minus e to the 1 over 2 bx plus 1 over 2 bx. And guess what? It's gonna be e to the you're obviously if you're adding halves of the same quantity, so that's going to be giving us just one or like one times of that quantity, right? So wait a second, what is 1 over 2 times ax plus 1 over 2 times ax? So basically it's ax, that's it. So we are successfully proven that we have got this final result, that is e to the ax equals, I'm sorry, e to the ax minus e to the bx equals e to the ax minus e to the bx, and hence proved, guys. So basically, you know what, the proof was like amazingly simple, right? You just have to tackle the infinite product because that was kind of bothering us, right? But if we talk like this infinite product, but if we talk about like if we know this result, so this is nothing actually, I can say, because the proof is just got submerged in some 2 3 pages. But the actual foundation was like talking about this thing, right? And honestly, I haven't talked about the infinite product of hyperbolic sine function yet, so I think I just thought let's just talk about this, why not in this video? So I just did that, right? And after all these things, I can surely say that you cannot say that Aman did use anything which he hasn't proved yet, right? So yeah, that's what my philosophy says actually. If I'm just using something, let's just talk about the proof of that. Let's just talk about the thing that let's just talk about the you can say where did that thing belongs to, right? Instead of just using that, let's just talk about from where it came from, it comes from. So yeah, that's how you can say. I'm not sure, I'm not a mathematician, but yeah, I'm a mathematics lover. You all know about that. So yeah, that's all I can say here. Okay, and yeah, I'll surely try to just bring videos regularly on regular basis, right? But like honestly, I would say that yeah, it's gonna be Saturday again. But yeah, I'll make sure that the gap would not be 2 weeks, like would not be of 2 weeks, right? I can make sure about. I can surely say that. Oh, wait a second, I'm not sure about the next moment. So I'll try my best. So yeah, okay. Goodbye, guys. And I think it's fine. And I love you all, guys. I love you all. Okay. So goodbye, guys. Take care. Love you. Love your life. Enjoy your life. And I would say we are not sure about the next moment, and we cannot do anything with our last moment. What we are having is this present moment. So let's just enjoy this, right? This only moment, guys, this only moment. So the last part of this video is kind of philosophical, but rest of the part is mathematical, right? So this video is kind of philosophy plus mathematics. Okay, okay. I think I'm just being weird now. Okay. Goodbye, guys. Take care. Love you. Enjoy, and please come up in my yeah. Obviously, I'm just gonna bring a lot of things for you guys like these, and let's just go through once because I think I can complete 30 minutes of this video. I love those things actually. So basically what we have to prove here is this thing, right? So we did understand what is the hyperbolic sine function, and then we just went for the relation between sine and hyperbolic sine function. So we did use of these things, right? You can understand that. And then finally on this page we have related the hyperbolic sine function as minus I times sine of ic, right? And then we using the sine Euler's infinite product of sine function, we can just talk about the infinite product of the hyperbolic sine function as well, because we have a relation, a very amazing relation between those things. So we just got this infinite product right over there, and using this infinite product, this is very easy to prove this down, prove down. So we just did that. Okay, it's done. Goodbye, guys. Love you.